Okay, we're trying to find the indefinite integral for this expression right here. The post didn't have an h here for hyperbolic sine, but I'm sure that's what was intended. So this is what we're evaluating right here. I'm not going to try to mimic the directions in the post. I'll just show you how I would do it. The key is to got to be very careful in keeping track of what's going on. So we're going to use integration by parts twice. This is the first time. I really probably should have used a 2 here, but so we're going to let the direction we're to let u equal the hyperbolic cosine of 3x. That means du would be 3 hyperbolic sine of 3x dx. And then if u is equal to hyperbolic cosine of 3x, dv is the definite integral of everything else, which would be the hyperbolic sine of 4x. So v is 1/4 the hyperbolic cosine of 4x. And then if we apply the integration by parts formula, u times v is 1/4. I'm just going to quit using the word hyperbolic. Cosine of 3x, cosine of 4x, minus v du. Well, v times du will give us a minus 3/4 here. The integral times the definite integral of sine of 3h cosine of 4h dx. And so this is what we've got up to this point. But now for this integral right here, we've got to use integration by parts again. Instead of changing the letters, I still used u and v. This time I'm going to let u equal the hyperbolic sine of 3x, which means dv is the definite integral of everything else, the hyperbolic cosine of 4x. So du looks like this, v looks like this, and applying integration by parts, u times v is 1/4 sine of 3x sine of 4x minus v du. Well, 1/4 times 3 is the 3/4 hyperbolic times the definite integral of hyperbolic sine of 4x times the hyperbolic cosine of 3x dx. Okay, so we're going to take this expression right here and substitute it for this. So we'll have 1/4 cosine of 3x cosine 4x, that's equivalent to this, minus 3/4 times what I substituted for this definite integral right here. And that's 1/4 sine 3x sine 4x minus 3/4 times the definite integral of, okay. Now I'm going to distribute this negative 3/4, so this will become a negative 3/16. This will become a positive 9/16. And now here's the key. This definite integral right here is exactly the same as what we started with. So we can move this term to the left side of this equal sign, and I'll have 16/16 of this definite integral minus 9/16, which leaves us 7/16 of this definite integral on the left side, indefinite integral on the left side, and all this mess on the right side. And so now if I multiply both sides by 16/7, I will have the antiderivative for this thing right here. So 16/7 times this 1/4 will give me 4/7 times this term, those factors. I won't show them. And 16/7 times this will be minus 3/7 times these factors. And there, now we can finally add the constant of integration. Here's what it looks like. On Desmos, here's the antiderivative. There's the 4/7 and then minus 3/7. There's the constant of integration. Now if I take the derivative of that function, That's this green dashed line. And that happens to match the integrand for the indefinite integral I was trying to evaluate. So that kind of proves that that's your antiderivative right there. There you go. Hope that helped. If you have any questions, post a comment.